again. All right, so I hope so far these videos are becoming quite helpful to you, and I'll continue doing them. Please give me a little bit of feedback if you can. I know you're not able to comment on these videos due to certain restrictions from YouTube, but feel free to send me a message on live grades, email, remind messaging, and Google Voice, so I can know what's helping you, what I can continue to do, or maybe I'm not doing something at all that you think could be helpful. All right, so we are now at day 10. That is 2 school weeks that you have not seen me in person, and I know you guys probably miss me just as much as I miss you. All right, so we are getting in to 7.2 in your chapter in your textbook. So make sure you have your textbook ready. I'm not going to reference that all too much, but I am going to reference your notes. So whether it's on a computer or that you have it printed out, go ahead and grab those. All right, so we again are on day 10. Day 10 is multiplying binomials. So we should know what a binomial is at this point. It is 2 monomials together creating a polynomial. What we're going to be doing in this section is we're going to take 2 binomials, multiply them together, and create a different polynomial. All right, so there are 2 ways that we can do this. The first method is the distributive method, or using the distributive property, which we've used all school year, so this should come relatively easy to you. And then the other method we're going to use is something called the FOIL method. So I'm going to start by showing you the foiling method on this video first. In your notes, that's actually the second method that I talked about. So skip to the second page of day 10 notes to look at this. All right, so the FOIL method is called just that because each letter stands for a particular term. So I'm going to start by writing that to the side of my board and referencing that. And I'll try my best to make sure my head doesn't get in your way. Now, let's look at these 2 binomials. Again, I know it's a binomial because I have a term, I have a second term, therefore 2 monomials producing a binomial, and then the same here. If I wanted to multiply them together, let me take a step back. I know I need to multiply these together because I have a set of parentheses next to another set of parentheses, which tells me they're multiplying. All right, so keep that in mind. If you see them next to each other just like this, it means multiplication. All right, so my foiling method, again, each term stands for which set of terms I'm going to multiply together at that time. So the F says, let's take the first 2 terms, okay, the first term in my first binomial, the first term in my second binomial, and we're going to multiply those together. All right, so I would have x times x, and we would get x squared. All right, so far so good. Now, my second letter, O, stands for getting the 2 outer terms and multiplying those together. So notice how if this is a straight line, I have 2 terms on the outside. So I'm going to do x times -7. So x times -7. I knew that looked funny. And I would have -7x. All right, so far so good. We're halfway there. The I says I'm going to multiply the 2 inner terms. So this 3 is the inside term, and this x They're the two inside terms. So I would have 3 times x, which would produce a positive 3x, so I put that plus in front of the 3. All right, so far so good. And then my L stands for the two last terms in the binomials. So I have a positive 3 times a negative 7, so positive 3 times negative 7, which produces a negative 21. All right, so far so good. You multiplied everything through, which was the very first hurdle to overcome. Now we have to combine any like terms that are combinable. Therefore, we're going to look to see anything that has the same letter and the same exponent, just like we talked about from the last section. So the only x squared I have is this blue x squared, so that's good, meaning there's nothing else that can combine with x squared. Then I have an x, and then I have another x, which means these two are combinable. So I know the x is going to be there. Negative 7 plus 3 would be negative 4. All right, they're good now. And then negative 21 just drops down because there's nothing left for it to combine with. So this is my answer. All right, so there's really just if you count foiling as 4 steps, there's really just 5 steps. But if you count foiling as 1 step, there's really just 2 steps, meaning you're going to foil, you're going to multiply, and then you're going to combine your like terms, and then you should be good to go. All right, not too bad, right? So now let me take the same exact problem and show you the distributive method or the distributive property. So if we remember when we use the distributive property, let's say, I'm going to erase all this first. If I had this problem and I asked you what that 3 was doing, you would tell me that 3 is multiplying by each one of those pieces. And then if I asked you to solve, most of you would know that we have to distribute, meaning we're going to multiply each piece by that 3. So I would end up getting 3x minus 21. All right, so again, we've done that all school year, and you should feel pretty familiar with doing that part. But let me put that original binomial back and then show you the distributive property and how we can utilize that to multiply these two binomials together. All right, so we can clearly see there's 2 terms here. And if I know that they're multiplying, I can take the very first term and multiply it by each term one at a time as though I'm distributing it. If this 3 wasn't here, I'm going to distribute the x to x, which would produce x squared. And then I'm going to distribute x to negative 7, and I would get negative 7x. All right, so far so good. Now, I have to remember that I also have that positive 3, and I need to distribute that positive 3 to each piece as well. So I have 3 times x, which produces positive 3x, and I have 3 times negative 7, which produces a negative 21. All right, then I'm going to go through and combine any like terms. So just as you did last time, I see that x squared, there's only one x squared, so it's already simplified. I have 2 x's, which means I can combine like terms. So I have negative 7, positive 3, which means I actually have negative 4x. And then I have my negative 21. All right, so same exact answer as what you just got, but I used a different method. All right, so in your notes, I gave you a different example for you to look at, going through the distributive property and then going through the foiling method as well. Whichever one you feel most comfortable with is fine at this point. So let me show you. I'm going to show you one more example to make sure that you feel good to go before I move on. And then I'll also show you that same example with both of the methods. All right, I'm back. So all right, again, we're going to do both methods. I'm going to do foiling over here, and then I'm going to distribute over here. All right, so if I foil, it tells me that the very first terms I'm going to multiply together first. So y times y would be y squared. Then I'm going to multiply my two outer terms together second. So I have y times plus 2, which is positive 2y. All right, not bad so far. Then I'm going to take my two inner terms, which are negative 8 and positive y, multiply those together, and I get negative 8y. And then finally, I'm going to take my two last terms, which are the negative 8 and the positive 2, and I would get negative 16. All right, so at this point, I've actually done all the multiplication steps, and I want to combine any like terms that are there. So y squared is simplified. I have 2y and I have negative 8y. They're like terms because they both have a y. And then I would get negative 6y. And then negative 16 is the only constant, so that remains the same. All right, so when I multiply these two binomials together, I produce the answer y squared minus 6y minus 16. Let's see if I get the same exact thing whenever I use the distributive property. All right, so distributive property, I'm going to take one term at a time and multiply it by each term in the second binomial. All right, so I have y times y, which is y squared. Then I have y times 2, which is positive 2y. All right, and then my second term I'm going to distribute is that negative 8. All right, keep in mind it's negative because I have that subtraction sign. All right, so I end up getting negative 8y minus 16. All right, so far so good. Now let's combine like terms. So again, y squared is the only y squared, so it stays put. These two terms are like terms, so we're going to combine those. I would get negative 6y, and then I have negative 16. And as you can see, I got the same exact answer. So whichever method you prefer at this point is fine. Just pick one or practice both of them and complete, well, I lost it. There's a maze that you have to do. And then you're going to complete this maze. Please make sure that you show your work, whether it's on the maze, on a separate sheet of paper, and then as you're working, if you're not getting the correct answer, make sure you reach out to me. I will let you know if you don't put your answer in standard form, which it should come out that way anyway, but if you don't put your answer in standard form, you might think that your answer's not there, but it is. So if you notice it's not in standard form, rearrange it and then look for your answer. All right, so now you are through day 10, and we will be getting through to day 11 here shortly. I hope you guys are doing well, and I hope to see you soon. Bye-bye.